Hashtag on time crew once again, always on time crew. I'm telling you, we're on a crazy streak right now. What's up, Rod DC? Try refreshing if you're still getting that network error. What's up, MGene? How you doing? What's up, 88 Opus? What's up, YGBSM? The Dev 08, how you doing? Good to have you. Welcome to another episode of Mastermind Academy. It's gonna be exciting tonight. We got some fun stuff. Just getting set up here. I'm not as unprepared as I was yesterday, but I'm still pulling up some windows, moving some stuff around. I was doing a little bit of work right before this. Oh, what's happened to my, oh, it's just smushed. Let's see. What's up, developer Desmond? How are you doing this evening? Let's turn this on. Let's get the metrics up to make sure I know if we're dropping frames. I think we've been doing pretty good on not dropping frames for the most part. Let's see what else we have here. Let me move this window. But how's everyone doing tonight? Welcome to Thursday. Welcome to what will mark the end of the first half of this boot camp. You made it halfway through already. And that the time crept up on us. I didn't even realize this. I did realize at the beginning of the week that it was week 4, but when I really think about it, that's pretty fast. Yeah, we're already halfway through, so you should be excited. You should be proud of yourself. Let's see what's going on here. Let's bring this up. Let's close all this stuff out. Make sure, you know, those precious computing resources, that's loud. Those precious computing resources aren't being taken up by things that we don't care about. There we go. We got a little bit of a background sound. I don't even know if you guys can hear that, but either way, not a big deal. But what are we going to be learning tonight? So we're back with deCoded. We are going to be diving deeper into our journey into software engineering and computer science tonight with loops, a very integral piece of software development, software engineering. We dove into it a bit with our first FizzBuzz program. Again, that was just for fun. Don't sweat it. Tonight, you're going to understand all about loops. We're going to dive into the different types. We're going to dive into when and why you use them. We're going to get hands-on and write all this stuff, so it's going to be dope. Let's see. And Friday's Eve. It is in fact Friday's Eve. Yeah, I hope you're enjoying your Friday's Eve. I am enjoying my Friday's Eve. I thought that at work we were going to have to do some crazy stuff for some more of the COVID stuff. But it sounds like we're going to dodge a bullet with this, and we may not have to do it. So I'm pretty excited, because my weekend was going to get eaten up, probably many of my weekends, but I think we're all good now. I've been going to every class of every week. The greatest, Rob. Congratulations, first off. Excellent job. You get the perfect attendance award. Pull it out of my pocket. There you go. You got your perfect attendance award, and I'm proud of you. I'm glad you've been here. Concepts and how does it been helping? That's awesome. That's great. Image above, don't worry, it's safe for work and relevant, even if it's not. Like I said, we make mistakes. Oh, they actually went to the site. That's amazing. That actually is that's very exciting, actually. I didn't stay on that long because I had to go eat dinner and spend a little time with my wife. That's awesome. Yeah, they tweeted at us today, which was cool, and I need to go respond. I know y'all can't see it. Let's yesterday we did in fact go raid the AWS channel. They were streaming when we got off of our stream, and we raided them. And check this out, they went to our site on stream. That's dope. Now AWS, if you're watching, hey, we're just, we're pulling the YouTube card. We want some sponsors. Okay, we want to be able to do some wild stuff. We want to be able to go build the craziest apps on the craziest infrastructure with the craziest tools, and we want you to pay for it. So yeah, let's do it. I'm gonna pass around the company. That's dope. I love it. That's exciting. First off, also thank you all for all the kind words while we were there. Again, this community is ours, and I think everyone's doing an amazing job at. Hey, we're getting our names out there together. So I really do appreciate that. But we won't let that go to our heads tonight. This is just that was just another step. At the end of the day, I love you, AWS, but everything that we do, let's be honest, is on the path to getting we're trying to get on the radar of LaCroix. Plain and simple, that's what we're going with this. We're not gonna get there alone. So you know, Prime is also working on this as well. We are going to be the sponsors of we're gonna be the face of mineral fizzy water in the tech industry, and it's gonna be pretty dope. But let's do this tonight. I'm gonna pull this up. Oh, first, actually, I have 2 or 3 quick announcements. Real quick. One, I don't know if it was this stream. I don't know if it was deCoded or if it was Horizons, but something ran into my window, and I was like, "What the heck is that?" Like, did anyone hear that? No one heard it. But I wasn't crazy. It was, in fact, a bird did run into the window, and unfortunately, the bird did die. I found it outside the other day. So that did happen. I'm just glad that I wasn't crazy. That does scare me a little bit though, because every time you see birds running into windows, it's usually in scary movies, and it means there's something bad in your house. So that's a little bit scary, but you know, it's fine. It's fine. I'm not crazy. That's all that doesn't matter. I mean, that's all that matters. And then the other piece of this, the other announcement is that, oh, hello, Jitter Ted. How are you doing? Welcome to the channel. Thank you. Welcome, party of 23. You came in right at the right time. We're just doing some announcements before we get started. Jitter Ted, let's you know, first let's do a shout out. Jitter, I'm a bad typist. Today I'm also going to try not looking at my keyboard at all. So shout out, and again, every raid also you get that. You get the shout out. I appreciate you coming by. What were you doing on stream today? I always like to know, you know, to check some people out. We'll check out your Twitch channel. Let's see. Actually, let's go here. I'm not logged in. Ooh, so I got right here and I see Java, and that scares me. So that's dope. Let's see, back to Java, celebrating 25 years of Java. Well, I'll keep my Java comments to myself. I'm someone who had to manage, you know, managing the JVM was never fun for me, but yeah, it's pretty dope. That's awesome. Thank you so much for the raid. Thanks for coming by. Hope you guys stick around for a little while, learn a little bit about loops. Tonight we're in deCoded. This is our apprentice level of a deCoded bootcamp, where we're going to be diving into software engineering and computer science. This is the kind of beginner series, and we'll actually have 2 more parts of this that are more advanced. This is an 8-week course. Yeah, we are finishing up the 4th week right now. So dope to have you. Way to start off the stream. I really do appreciate it. So the first announcement was that the bird did fly into my window. That was a thing. And the second one is that we are starting, we're going to be doing 100 days of code starting June 8th. And people have been asking me about this because I brought up in the beginning. We're waiting until June 8th because that is going to be at the point where, like, you've been at least introduced to most of the tools, so you can really start to get going. Like, maybe you still have to catch up on everything, but you've been introduced to it at least, and you can kind of start to just play from there. And so we're going to be starting June 8th. It is language agnostic. Whatever you want to do, you can do. So I'm probably going to start off. I'm trying to plan mine out, and I encourage you to maybe plan out some things. I encourage, like, all of us to kind of maybe we can try to put together a default plan before this for anyone who just wants to follow something. And maybe we'll put together a default plan, and then everyone else can just do what they want if you know what you want to do. But I want to do 2 things during this time. I want to learn Rust. So I'm going to be doing this with Rust. I am going to participate in this 100 days of code, which is, again, yeah, it's 100 consecutive days of code. You're supposed to do it for an hour a day. I understand that may not be feasible every day. But, you know, do your best to, you know, get at least some coding time in. And it also doesn't need to be strictly development. I would say just working on the craft of software engineering, just working on getting better, doing things outside of your normal tasks in learning, but just really getting hands-on and practicing. But I'm gonna try to learn Rust, but I'm also gonna try to build a few tools. A lot of Twitch streamers build a lot of tools to make their channel a little more efficient, and I want to do the same thing. So I'm going to be doing both of those. I don't know if Rust is going to be a good language to do that in, but I'll be doing a little bit of both of those, so I think it'll be fun. And we'll have a few check-ins. I'll give you the structure and the breakdown on the 8th. We might go over it at the end of next week, but on the 8th we'll hop into it. Greetings from Brazil. What's up, True Orcha? How you doing? Or True Orca? I'm assuming it's one of those. Hopefully I got it right. Writing smelly code for my upcoming crafting Java course. That's dope. That is dope. So first off, Java is a great first language to know. Or Java is a great language to know, period. Super crazy popular, used at a lot of places. I just am, Java was the first language to make me feel like I could not program. But Java's cool. I've done a little bit with Java. I'm a Go fan myself, but that's pretty dope. Definitely let us know when you get that class done. I would love to check it out, especially for any of you on here who are trying to learn Java. A lot of stuff here, but yeah. Groovy tool building is so useful. Yeah, I agree. I think that's one of the biggest problems for anyone in the pipelines course of people getting into something like Jenkins. Groovy was a big hurdle for a lot of people, but yeah, that's true. I do like what Groovy can provide. Okay, so let's get the slides out here. We're gonna get started because tonight is going to be I feel like loops, the concept of a loop is simple, but understanding the differences between the loops and kind of getting hands-on with them can be a little bit of a mind melt a little bit. So we're gonna start now, and we are gonna run through. There are 18 slides, and I think that I was thinking about something earlier today, and we might include one more slide in here that's not here. But we'll see when we get there. We'll see how much we get through. So let me get you the link for anyone who's not a part of the Google Classroom. There is a Google Classroom for this course. For all the courses, you can see the codes below, or you can do !classroom and you can get that. But I will share this. Let's see. Where did this go? Let's bring this back. I closed too much stuff. All right, there we go. So Java still used way more. Oh yeah, Java's like super used. Like it was so big for so long, and like it's a good language. It does a lot. Like it's super useful. But it has some because of its age and underlying kind of the way because of its origins, there are just a few things that I think are a little more. If you're starting a new project today, I probably wouldn't consider Java, but that's just because I don't know Java, to be honest. But no, it does a lot of dope stuff, and there are tons of Java jobs, like tons of them. Groovy was a statement of excitement. Yeah, I mean, again, everyone has different experiences coming from different places, but yeah, it is verbose. It's very, and I think that's my problem with it, or that was my problem with it, is that it's verbose. I think now it will be a lot easier. Like, I'm very confident that I could hop into a project and do it in Java if I needed to, but I don't know. But maybe we'll do some Java stuff. Maybe we'll do some language comparisons. And kind of see what people like and what they don't like, and show there's a lot of things that Java is really good for, and I think that's worth highlighting as well. But tonight we are doing I think we changed the name of this. We'll leave it at loop to loop, but tonight we're going to be talking all about loops. So get ready, get set, get ready for a little bit of deja vu with loop to loop, the story of repeating, I guess, ending at the beginning. That's what we're going to be doing. So let's get going. What are loops? We're talking about loops, but what are they? It's a concept that applies across the board here, and no matter what language we're talking about. It's implemented differently in different languages, but we're going to cover that as well. But let's talk about what loops are. Loops are simply used to run a set of instructions multiple times. So we said that all that programming was, all that computer coding was giving instructions to the computer so that it can run them automatically. And this, if we're giving instructions to the computer, a loop allows us to run a set of instructions multiple times. Now, again, that's a simplified version of it for you, but yes, that's all it's intended to do. There are different types of loops. There's a for loop, there's a while loop, there's a for each loop. We're gonna go over all those. There's a do while loop. There are multiple loops, but I just wanted to give you on one slide that there are multiple ones and give you two of the main loops that you're gonna be running into. And loops, this is very important, loops run for as long as a scenario that you specify is true. So as soon as you see that word true, you should automatically be thinking about Booleans. We learned about Booleans, true and false. And we also learned last time that we could use those comparison operators to set up conditions for if statements to run. And these work the same way. They use those comparison statements. They use those comparison operators to determine whether or not a condition is true or false, and that determines if the loop runs or not. So all it is a way to run a piece of code multiple times, and it's not just twice, it's not just 3 times. You can determine the amount, and we're gonna learn how to do that tonight. But it'll run as long as you say so, basically. So that's actually the hardest part, I think, of getting loops right, is learning how to phrase the scenario per se, learning how to say how many times you want this thing to run. So let's hop right into it. Now, let's just hop right into it. I was going to give you some more, I was going to preface a lot, but we're just going to dive right into it. Ask all the questions you want tonight because it will be a little bit confusing. There are, while again, the concept of a loop is fairly simple, that it just runs, a set of instructions multiple times. The intricacies of it can be a little tough, so it's okay. Ask as many questions as you'd like. So while loops is going to be the first loop that we're going to talk about, and we're going to hop right in and create one. But what is a while loop? A while loop executes code for as long as the scenario you specify is true, and that's going to be a statement that's true about any loop. And so when you see a while loop, we're gonna see when we're gonna read over how it's kind of set up, and it's basically you're gonna execute code while this scenario is true, and that's really how I want you to read it, because it'll help you kind of understand what a while loop is. While loops can create infinite loops pretty easily. We're going to talk about that as well. I think there's a whole slide later on infinite loops. The continue and break keywords give you additional control of while loops. So all this is on one slide, but all this is repeated on individual slides after this so that we can dive into it. And let's talk about when to use while loops real quick, and then let's see a while loop in action. So while loops are best used when you aren't sure how many iterations of the loop needs to take place. Now, let's talk about iterations, and I think there's a slide also on iterations, but right now think of iterations as the each time a loop runs, if a loop runs multiple times, each time that loop runs, that is an iteration of the loop. So if you aren't sure how many times that loop needs to run, you can use a while loop, but this is when it's best. You can actually use this in lots of scenarios, but this is kind of when it's best used. This is kind of best use case is to use it when you aren't sure how many iterations need to take place. And then the last thing we're going to talk about before we see one is incrementers. This isn't the true name of them, but incrementers, the famous I. You've probably seen I in a lot of example programs. And here it just says we can use a variable to track and control the number of iterations of our loop, and then that we can increment the incrementer, so then we can add or subtract from that incrementer to determine what number we are on. Now, the reason I'm not sticking on any of these slides is because all these concepts kind of work together, and I don't think it's necessary for you to read these and like to memorize what's on these slides for you to get it. I think it's better for us to just hop right into it. And I think we're gonna stick with Python for most of this, mostly because actually we'll probably use JavaScript tonight as well. And we'll use Go for a bit of it, but Go is a little unique in that it only has one type of loop that you can use in different ways. So we'll dive into that. Okay, so let's we're gonna create a file. So I encourage you to head over to REPL.it. If you're still uncomfortable with creating your own file and running it via the command line or running it in VS Code, I highly encourage you to go to REPL, REPL.it to be able to write some of your code. And to be able to follow along if you want to follow along. But right now, I highly encourage you just to watch and to let's start to cement in the concept here. So I'm gonna go into, again, I'm gonna do my best not to look at my keyboard, so bear with me. I'm trying to learn how to be a better touch typist, because I've gotten my blind touch typing speed from 30 words per minute up to 40 now. But my if I'm looking at the keyboard, I can get up to around 85 words. So I'm trying to bridge that gap a little bit. So I'm gonna do my best not to look, but I will make lots of mistakes. So don't get annoyed with me. And I looked immediately. I just had to get myself oriented, you know. Let's go. We're in deCoded. Let's go in. Let's make a new directory. What are we gonna call this? Loops. Pretty easy to do there. And we're gonna go into our loops directory, and we are gonna make our first while loop. So I'm gonna say vim while.py. So let's do our while loop first. Now, what is something that you might want to do with a loop? What's something you might want to do? One of the most common things is to count. Numbers, is to print out numbers. We saw this when we dove into FizzBuzz a little bit, but let's say we wanted to print the numbers 1 through 10. If we want to print the numbers 1 through 10, how could you do that? I mean, the easiest way would be print 1. And you know what? Just so I don't have to type as much. Oh, I'm struggling already. I'm struggling. It's gonna be hard. Maybe not 1 through 10. Let's go 1 through 5 for now. Let's go 2, 3, 4, and 5. So this is a piece of Python code, and it has 5 print statements to print out the number 1, then the number 2, the number 3, then the number 4, and then the number 5. Let's save that and exit, and let's run it real quick just to make sure it does what we want it to do. And it does in fact print out. Let's make it a little larger. 1, 2, 3, 4, and 5. Great. That is a way that you can do that. But we, that's a lot of work. What if it was a lot more than 5? What if it was, to 1,000 or something? This wouldn't be a really feasible way for us to print those numbers out. And again, that's where loops come in. You can use all different types of loops to do this. We used a for loop last time to do this, but the way that you print something out is just with a print statement. And so we can use that bit of code multiple times. So a while loop looks like this. It runs while. The while keyword starts it out. So while, the same way like an if statement, you use the word if. A while loop uses the word while to kind of instantiate it. And it's while, and then you set the condition. Okay. And so when you set the condition, just like the if statement, it's looking for a comparison. It's looking for some type of comparison operator, some type of operator to evaluate to a true or false statement. It's looking for a way to evaluate to a Boolean. So if we want to say, if we want to print out to 5, we can do something like this. We also talked about the incrementer here. So let's actually go back to this. And in our while loops, we talked about incrementers and the famous I, and using a variable to track and control the number of iterations in our loop. Okay, so we know what a variable is already, but we don't really know how we can use it to track or control the number of iterations in a loop. So this is how you'll do it. We will create a variable. You can call it whatever you want. In all of the examples, again, it's usually I or X sometimes, but it can be whatever you want. It's a variable. A variable is just used to hold a value. So we can say I equals, I don't do symbols very well. I'm really bad at symbols. There we go. I equals 0. Okay, I'm really bad at symbols and the top row of numbers. So I equals 0. This is going to be our iterator. Let's put a comment up here so we know. No, Python is this. Oh no. Okay. Setting up an incrementor. If anyone's like, oh, it's an iterator, well, we're not there. It's not actually, but we'll get there. So we can actually also call this our incrementer if we want it. We can call it whatever we want, but we'll do I for now just because people use I. So if we're going to track the number of times something happens, it makes sense that we make this a number. So I'm going to set it to 0 for now. And so the condition that you may want to use when you're trying to do something like this is if I need to print out a number up until 5, I wanted to print while this number right here that we're going to be incrementing, I want to print it out while this number is less than 5. So I'm going to say while I is less than 5, go ahead and print out the number. But how do I tell it to print out a number? How do I tell it to print out the number? And again, I is a variable, so I can tell it to actually print out I. So I is 0 right here, and I can tell it to do this. This is what a while loop, the structure of it, a basic one will look like. It'll have some type of way for you to track, usually, again, this is very basic, a way for you to track it. So the incrementer, it'll be a variable setup, and then it'll give you the condition. So I say, while I is less than 5, go ahead and print out I. So again, this is the very basic structure. Now, this is gonna break. I'm gonna show it to you. It's okay. You just tried to run it on your own. It's not gonna break. It's gonna work, but it's going to do exactly what we said here. It is actually gonna set us up in an infinite loop. Where is it? While loops can create infinite loops. This is going to give us an infinite loop, but I just want to show you what it looks like, and then we'll dig into that. So I'm going to run this Python 3. All right, so right now this may be happening to your computer. It looks like it's doing nothing. It is printing out the number 0 over and over again, very, very fast. What's up, Cyber Barbie? I'm gonna say what's up in a second. We need to stop this loop first before it eats up all of our memory. It looks like nothing's happening. It absolutely is printing out the number 0 hundreds and thousands of times right now. So the way that you get out of this, an infinite loop, is to hit Control C, and it might take a little bit. It'll give you a little error there and tell you that you interrupted it via keyboard. And yes, and what we just did was set up an infinite loop. We were running a bit of code non-stop, basically. We got it into a state where it runs non-stop. We're going to talk about why that happened in a second. What's up, Cyber Barbie? Welcome tonight. Thank you so much for the love, first off. I think this is 2 days in a row. I really do appreciate that. What's up, all the 33 raiders from Cyber Barbie's channel? I already know. I was on there. I already know you were doing some Python stuff today. You guys were doing some object-oriented programming with classes. I saw you instantiating some classes and looking at constructors and all that stuff, so that's pretty dope. We aren't quite there yet, but we'll definitely be getting there. That's pretty dope. What's up, Many Flames? Good to see you here. Always love to see you here. What's up, Chelsea Carter? How you doing, Lita? How you doing? Welcome all. Come on in. We're just getting lit with some loops. Just learning a little bit about how loops work, the different types that you have available to you, some of the caveats with them as well. Sean says, and you never changed I equals 0, but if we incremented it past 6, it would have stopped. So that's exactly what the problem is. So we talked about those incrementers. We talked about an incrementer being a way for us to track what number we're on. So right here, we said I equals 0. We know that variables can change. I said, while I is less than 5, print this out. So the way that a loop works is it'll evaluate this statement to be true or false. If it is true, it will run this code. All right. When it's done running that code, it will start over again. Automatically, it'll start over again, and it'll evaluate this code again. And it says, hey, is this true? And it'll run the code underneath. It'll start over. And so it'll run this, it'll start over. Now, when this happens, let's walk through it mentally. We set up I equals 0 up top. The code says, hey, while I is less than 5, go ahead and print out I. So what is I the first time? I is 0. So the first time it runs, I is 0. Is 0 less than 5? Yes, it is. So it goes ahead and it prints out I. Now, when it goes around the second time, it says, hey, is I less than 5? I is 0 again. It's less than 5? Yes, it is. So it prints out 0 again. I is still 0. It says, hey, Is I less than 5? Yep, 0 is less than 5. That's true. Go ahead and print it out again. So we got into a state where if this is always true in a while loop, if this statement is always going to be true, it will create an infinite loop for you. And that's what happened to us. So this is where the incrementer comes in. We're using it to track. The last thing that we need to do is we need to increment this number. So basically it's like, hey, once this code runs once, we need to add 1 to the incrementer. We need to tell it that it ran once. So there are a couple ways to do this. The main one that people like to use is something like this, I++, which we talked about a little bit before. This does not work in Python. Remember that adds 1, minus subtracts 1 in other languages, but not here in Python. So the way that you add 1 to it is the easiest way is to do I plus equals 1. And this will, what is this? This is what we just learned about last time. This is an assignment operator. We are assigning we're assigning the value of I plus whatever's on the right as well. So what we can do is actually what happened here. So what's happening here? Whoops. What's happening here is the first time this runs, I will be 0. It will print out I. So I will be 0. And then it will add 1 to I. So now I is 1. And remember, variables can be changed. So now the value of I is 1, even though it says I equals 0 up here. So now that I is 1, when it comes back up, I will be 1 now. Is 1 less than 5? Yes, it is. 1 is less than 5. That's a true statement. It'll print out 1 instead of 0 because now I is 1. Then it'll add 1 to 1, which will make it 2, and so on. And so let's run this bit of code here. And we get 0, 1, 2, 3, and 4. We do get 5 numbers here, but we do not get up to the number that we want to get to. So why is that? Let's look at why we did not make it to the number that we wanted to get to. So we said while I is less than 5, one of the things we looked at when we did comparison operators last time is we said, hey, is 5 less than 5? Like, is that a true statement? No, that's not a true statement. 5 is not less than 5 because it's equal to 5. So what can we do to make this work? You have 2 options here. And again, you can be flexible. There's one answer that is usually more accepted than the other, but you could do this. If you wanted to print out 0 through 5, or 1 through 5, we'll worry about the 1 later. You could just up this to 6. Because when it gets to 6, it'll stop, but 5, it will print out because 5 is less than 6. So you could do that if you want, and we can see that run here. And we get 0, 1, 2, 3, 4, 5. So we do get the intended outcome, but the way that makes it cleaner, this is kind of confusing if someone were to look at it, doesn't really register. But it's to use the less than or equal to operator, comparison operator, to do that, so that when it gets to 5, it'll say, hey, is 5 less than or equal to 5? Yes, it is equal to 5. Go ahead and print that out. And then when it gets incremented, so it'll still get incremented, and then it's 6. So when is 6 less than or equal to 5, that's a false statement. Once it's false, this no longer runs. So a while loop only runs while the statement here is true, evaluates to true. So we'll run this again. Same outcome. Now, an easy way to make it only not start at 0 is to simply make our incrementer start at 1. And again, so this is a tool for you. The incrementer is a tool for you to, again, track the number of times your stuff is going to be iterated through. Now, this already goes against what I told you. This already goes against the best practices for a while loop. Again, generally the best practices for a while loop are when you're unsure of how many times this is going to run. But again, almost all the loop options can be used interchangeably. Again, they all fit in a different paradigm a little bit better. You'll learn which scenarios you might want to use one in as you kind of get a little farther along as you're practicing things. So this is our first while loop. All you really need to remember about a while loop tonight is a while loop runs as long as the statement is true. So do all other loops, but this is the kind of the simplest. And we talked about the infinite loop a little bit. Actually, we're gonna get there a little bit later, so I'll wait. Jackie, yes, we did get rated. We got rated twice tonight, actually. So yes, we did in fact get rated. Let me go up and answer any questions. Ask any questions about the while loop. We are going to do like 6 more things with while loops tonight. I wanted to give you the basics of a while loop right now. We're going to change this up substantially as we kind of go through some of this, and we'll talk about infinite loops a couple times. Sorry, yes, the infinite loop crash your VS Code. It can do that. It can do that. Infinite loops are pretty interesting. You will accidentally run into infinite loops. Forgetting to increment your incrementer is a common mistake, forgetting to do that. But yes, let's see. Also, just want to, for the incrementer, just remember, because we're learning different languages here, this is the kind of most common way. This is the preferred method if the language does allow it, but these are the other 2 ways you can do it. So other languages that will allow the plus equals is kind of the shorthand for this at the bottom. So all 3 of these do the same thing. All of them do the same thing. You can use any of them, but again, I would use the one, these are all kind of cleaner to kind of read, as you move up. But all of these do work. So I equals I plus 1 would do the exact same thing. Oh, Jackie, appreciate all the gifted subs. Here we go. I looked at my keyboard. I look at the keyboard. Okay, so I'm not gonna look at it. Jackie Alcine, there we go. Did I do it? Did it come through? Let's go. There you go. You are absolutely a VIP of the channel. Thank you so much. I do appreciate your support. Everyone, please thank your gracious gifter, Jackie. I do appreciate that. Oh, they're already VIP? Well, oh yes, you are already a VIP. Well, you're double VIP. Thank you so much. I do appreciate it. Definitely appreciate it. Everyone's so kind. You guys are just so kind. Okay. Now it's also worth noting this incrementer. It's very funny because this is how everyone teaches it. This is how everyone kind of learns it in the beginning. One of the things, I was working through a problem with someone, I tried to help them through this coding challenge, and they understood how to get to the place they were supposed to be. The problem was they thought that when you increment a variable like this, because everyone always shows it like this, they thought you could only increment by 1. That is not true. You can increment by whatever number you'd like. So I could count to 100 by 5s if I'd like, by changing the incrementer to 5 or to whatever I want. So they knew how to solve the problem, but they did not know. They believed they could only add 1 each time, and it was very confusing to them. And they wrote a lot more code than they needed to. And I understand how you would think that, well, that's wrong because we started at 1. Let's start at 0, so it doesn't look so crazy. So we go 0. We're gonna count from 0 to 100, and we're gonna skip by 5s. And so what'll happen is it's 0 the first time. It's gonna print out 0. It's gonna add 5 to 0. 0 plus 5 is 5. So the next time this runs, it says, is 5 less than or equal to 100? Yes, it is. So it prints out 5, adds 5 to 5. So now it's 10, then it's 15. And so that's also good to know, because I was very surprised at that. It made perfect sense. I completely understood why they believed they could only add 1, because you always see that you can only add 1. So yeah, it's just make sure you can skip numbers. You can add whatever works for you in the scenario. Okay, now I'm going to show you another way to use these while loops. Let's learn about some key phrases really quick. Actually, let's also do this really quick in JavaScript to show you that it's exactly the same. So I'm gonna create a file called while.js because we're gonna do a couple different things with JavaScript tonight as well. And we're gonna do stuff with Go, like I said, but you can do it the same way, and JavaScript's a little bit different. So I equal 1, and I'm pretty sure it's still just while. I think you have to put these in parentheses in JavaScript. I think while I is less than 5. I think print I and I++, I believe works in JavaScript. If not, I'm well, you know, we're just trying. We're trying. We'll look it up if this doesn't work. This feels right. I'm gonna run it real quick just to make sure, and then we'll just compare the two, just so you can see the difference, just so you can get comfortable with the different syntax. Nope. Oh, there we go. Not print. See, it's console.log. All right, and so again, this is also less than or equal to. So let's pull these up side by side really quick, because it's pretty important. Let's save. This is gonna make me do :WQ. I never do that. Oh, I didn't mean to quit. And no, there we go. PYS. All right, there we go. So look at these side by side. Shanahan, thank you so much for the Twitch Prime sub. Good to have you. Welcome to the channel. Oh, we got level 3 hype train going. Thank you all. I cut off a number of my in-ear alerts because first off, I'm pretty sure I have ADHD, to be 100% honest with you. I'm not, I mean, I've never been diagnosed, but my attention span, I get pulled off track real easily. Thank you so much for the hype train tonight. I really appreciate it. Definitely appreciate it. It's the first of the month too. Don't, hey, times are tough. You know, we're here to have fun together. You know, I just appreciate you all hanging out, making me laugh. You know, I've learned a lot from you all as well. But take a look at what's on the left. Take a look at what's on the right. We have basically, it looks almost the same. Obviously the syntax is a little bit different. And so I could put a thing here that says, you know, setting up an incrementor. I almost did it right the first time. And look, it's the same number of almost the same number of lines of code. The only reason it's different is because of these braces that have to be put in here. But essentially, we have the same thing in two completely different languages. So take it in a little bit, so that it's not going to be as scary to move on to another language. It's relatively simple. Now, when we go off to Go, it'll be a little bit different. Ooh, okay. Let's take a break from this. Let's thank everyone. Sean, thank you so much for the 1,000 bits. Imgene, thank you so much. Oh, we just coming through with the hype train. Thank you so much. I love you all. I love you all. This is amazing. I really do appreciate the love and support that you all give to me and that you all have for each other. I get my heart, it flutters every time I see people helping each other out in the chat or in Slack or in Discord, because I don't be doing it because I'd be lost and I'll be busy. But thank you. Oh, another 100 bits. I appreciate you all. You get the 1,000 bits badge now. You got a fancy badge next to your name. First off, I did not make the association. They talked about badges. I was reading about Twitch. You guys know I'm a Twitch noob, even though I'm learning. I didn't make the association of what the badges were. Even though I was looking right at them, I didn't really understand the concept of the badge. It's pretty cool that it goes right there. It's pretty dope. Oh man, I'm so I'm sweating because not because it's warm in this room, but because you all have warmed my heart. Thank you so much. I love that we're doing this together, but let's keep moving. I mean, feel free to keep the hype train going. I appreciate it, but let's keep moving so that we let's increment the hype train, I guess. So let's get out of here. I'm not gonna save any of this. Get out of here. Get out of here. Get out of here. And just because of that, I'm now really not gonna. Look here. Look. This is now in front of my keyboard. I cannot even see my keyboard now, and I will not, just for you, I'm gonna make it work. I'm gonna think about what I'm doing and I'm gonna make it right. So let's go back here. Let's learn about break. So there's a few ways we can control the flow of our loops, specifically our while loops, but yes, the break command. You can manually break out of a loop. Why would you want to break out of a loop? Especially when you are going to set up a scenario in which it runs and it's true. I can do the same functionality that we just did, utilizing a different set of logic. So what we're going to do is we're going to create a scenario for an infinite loop. And actually, let's look at that. Let's actually look at all the keywords first. and then let's go and let's practice them. So break is being able to break out of a loop. So, you know, if a loop is iterating, you can tell it to stop, basically, depending, usually it's done depending on a condition. I mean, yeah, you got to do it depending on a condition. So you can set up another condition inside of the loop in which the loop breaks. So we can do that. Then there's the continue keyword. So the continue keyword is so that you can end an iteration of the loop and move on to the next iteration. So why would you want to do that? So breaking will break out of the loop. Right now we're doing very basic things with our loop. Our loop is just a tiny bit of code. If you have a loop that has a bit of logic in it and it's making some decisions, you can actually have it skip, basically stop a run. Like maybe if some other scenario becomes true, you can have it in the current iteration but not break the loop. Like if it's supposed to loop through 20 times and on number 13 you need it to not do something, you can put a continue kind of above, you know, above where that logic happens, and you can end the 13th run and move on to the 14th whenever you're ready. And this will make more sense as we do it in a little bit. But there's break completely ends the loop. Continue ends the current iteration and moves on to the next iteration of the loop immediately. It won't run wherever it hits the continue. It won't run the rest of the loop. Like if there's more code underneath it, won't run it. It'll move on to the next iteration of the loop. Oh my gosh. Oh my gosh. Gotta get, first off, just gotta get your VIP there so you can get your badge. /VIP. Wow, YGBS. Oh, first try. Let's go. You might already be a VIP though. Oh no, you are not. Welcome to the VIP section. We're gonna have so many VIPs because you all are so great. Level 5, the best. We're definitely gonna be doing more giveaways because that's what I mean, if you're gonna make a hype train, then the hype train has to go to the store and pick up things to give away. I also am gonna do a poll on what you guys would like to receive for some of the giveaways. I was gonna grab some Raspberry Pis and stuff, but I was like, you know what, like, do people want that? Like, I like Raspberry Pis, I like some of these other things, I like the Google Home Minis, I like tech products, but I'll see what you guys want. Thank you, man. I'm gonna, you all are getting a video made about you. I'm working on my YouTube game. I'm working on, I promise you, it's coming. I'm gonna do a tribute to all of the amazing people. Oh my gosh, Chaos, thank you so much for the 1,000. I gotta keep moving though, because thanks for getting me to level 5 of the hype train. I appreciate you all, truly appreciate you all, but we gotta keep moving so that we can finish, because I always tell you I'm gonna get you all early. Today I'm not telling you I'm gonna get you all early, and if we're taking this much time away for the hype train, you're gonna be here for a while. Oh cool, Pause to be super cool. I got y'all. We're working on some things, but yeah, we'll get some Raspberry Pis to give away as well. But the break breaks you out of a loop. Continue ends the current iteration and continues on to the next iteration of the loop. And then I have the slide in here that talks about infinite loops and running forever. So you can create a condition to run loops infinitely. You will accidentally do this. And one of the ways that you can do this is this while true. So remember I said that the while needs to just evaluate a statement to true. Well, you can just say while true, and that will cause the loop to run infinitely. And we're gonna see that in a second. And I thought I wanted to show you something different. Nope, those are the 3 things I wanted to show you. So infinite loops, we're gonna create a scenario really quick where we create an infinite loop, and I'm gonna show you how to do the same thing that we just did by counting to 5. I'm gonna show you how to do it with an infinite loop and using the break keyword. So let's do it that way instead. So let's do let's vim while, no, not while, let's vim break dot py. There we go. All right, break.py. Let's create our, let's set up our incrementer again. And so I got equals right the first time that time. I equals 0. 0, no, not 9, 10. There we go. I equals 0. So we're gonna say while true, and I'll show you what this, I'll show you this really quick. Come on, while true is a capital in Python. That feels wrong because it didn't change colors. T, capital T. All right, cool. Let's go while true. print oh, what's happening? I don't have autocomplete on. While true, print I'm true. And all right, so we actually don't need this incrementer up top, but the while true will just set up a completely infinite loop, and we are going to run that really quick. Break. I'm struggling. Oh, this is uncomfortable. I'm faster when you guys aren't looking at me type, to be 100% honest. But okay, that sets up our infinite loop. It's running over and over again. You can see it blip down here every so often. It is in fact running. Let's get out of this. So infinite loops are something that you can utilize. It's not necessarily a bad thing. You can utilize infinite loops again when you don't know the number of iterations and you're looking for something. While true can be pretty powerful. So let's get this set up again to print out numbers, and let's okay, this is gonna, I don't know how to do Vim without looking at my keyboard, so hold on. I'm gonna try to delete inside the parentheses. So delete inside parens. Nope, undo. Hold on. Delete inside parens. Oh my gosh, hold on, one more try before I look. Delete inside parens. Boom, I'm getting there. Okay, undo. I did undo. All right guys, I'm struggling. Delete inside parens. So in here I'm just gonna put the I in here before I confuse myself. So we're gonna print I, and then we're gonna do I++. So we're gonna set this up the same way that we had it before. So I plus equals 1. Okay, so now if this is an infinite loop and we are printing out I and we're adding 1 to it each time, what do we think is going to happen? What do we think is going to happen here? It is going to infinitely count up by 1. So every time this runs, it is in fact adding 1, and it is doing it very quickly. You can see how fast we are getting up there. We are already in the are we already in the millions? Yeah, we're already in the millions. I can't really tell. I'm pretty sure we're in the millions, 4 million, I guess. And it's running very quickly. Infinite loop is adding 1 every time. This is essentially the same code we had last time, but because the statement will always evaluate to true, it just keeps running over and over again. Which again can be problematic. This is a problem. That is not our intentions. Our intentions are to count to the number 10. Let's say the number 10. The way that we can get out of this is we can do this. We can say, hey, first thing I want you to do is I want you to check if the number is greater than or equal to 10. So I can use our if statements, the stuff we learned last week. I can say if I is less than or equal to 10, go ahead and print I. So go ahead and print it out. Actually, no, let's do it a different way. Let's do it this way. We can say if I is greater than 10. So we only want it to run until I is equal to 10. And so let's say if I is greater than 10, I want you to break this loop. Otherwise, go ahead and print I. So what this will do is it'll say, all right, I is 0. While true means go ahead and run. Like that's good to go. It's a true statement. Let's go ahead and run. The first time it runs, it'll say, hey, is I greater than 10? Is 0 greater than 10? Nope. So it will not run this code. It'll go down here and it'll print it out. And it'll add 1. Then it'll be 2. Is 2 greater than or equal to 10 or greater than 10? No, it's not. So it'll run this code. But it'll go all the way up to 10. It'll say, hey, is 10 greater than 10? No, it is not. Go ahead and print out 10 down here. Then 10 I will be 11. It'll go back up. It'll say, hey, if 11 is greater than 10, run break. And it'll say, yep, 11 is in fact greater than 10. It'll run this break statement and it will stop. I hope. So let's run it, and we get 0 through 10. And let's look at that again. Get your eyes on it. Let's compare it to whoops, not that one. let's compare it to wild.py. And let's look at how we did it differently. So this one, let's get this back to where it's only counted to 10 and 1. Okay. Now see how these things are different. Now let me go back. Yeah, let me go back to the chat now. Anyone have the new System 76 laptop with Ubuntu 2904? I updated my Galago Pro. I do have a Galago Pro. Sully, I have upgraded to 20.04, and so it works well. I don't have a newer one. Mine is from like 2 to 3 years ago, but it works super well. It definitely works super well. I do really like the new lemur. It got a lot of battery life, but I'm actually, because of Windows Subsystem for Linux, I'm probably going to be trying to make the move fully to Windows, to be honest. Not because I love Linux, I'll always be a Linux lover, but just for a number of tools that I kind of need to do this. It's gonna be nice to have some consistency, but that means I probably will start using that System 76 laptop back again to do the boot camps, to be 100% honest. Oh, how do you stop this loop? Sorry, it's Control-C, Enigma. I'm sorry. You can either close the terminal or close your program or hit Control-C. Control-C is how you would do it on, I think, every single platform. Yeah. Please help. I'm sorry I missed that. Oh, Command-C. I think I feel like Control-C works as well, but I don't know. All right, Manny Flames, gotta go to bed. I feel you. Thank you for coming through. Thanks so much for supporting the community. Really do appreciate it. Am I waiting for WSL 2.0? So WSL 2.0 ships out in Windows version 2004, which I believe released today, actually, and it's shipping out today. But you can install WSL 2 actually already. So kinda, I'm waiting for the official release, but I already have it. So it's kind of nice. It does everything that I need to do. I'm gonna give it a go. I don't think I'll ever be pulled fully away from Linux at all, but I'm gonna try to make it my main workhorse though. Yeah. Oh yeah, Enigma. You probably let it run for so long. It was taking up so much memory and stuff that it wouldn't even accept your command. It probably would, but it would probably take a while for it to register. But I'm glad you were able to get out of there. Okay. So 2 different ways of doing it. And again, this code will go up to GitHub. You'll have time to look over it. It's okay for this to be very confusing. I understand if it's very confusing. What I want you to understand is that a while loop runs as long as the statement is true, and that it has some keywords that you can use to kind of control the flow of it. We use the break keyword to break out of the loop. So this infinite loop that would have been created with the while true, we broke out of it basically by setting up another condition, by setting another condition to check for and using the break command to get out of it. Now, let's go ahead and take this and let's change this to be, let's use the continue. Let's see why we would want to use the continue keyword. Whoa, that's not what I wanted to do. Q exclamation. Let's use the continue keyword. Let's see how we would use that and why we would want to use that. So let's copy break.py to continue.py, and let's modify that. Let's modify that accordingly. Can't type. Okay, first off, also, what's up? It's Sabotage. Welcome to the channel. What's up, Corrupt? Welcome. Introspective Samurai, welcome. Lita, welcome. You know, we've already been acquainted. Slime Yeshua. Oh, that's all the bits. Never mind. That's all the bits, not the follows. What's up, Riff? I'm trying to say what's up to the new followers because a lot of people came in during that time. Struggling Black. We were introduced earlier today on. I saw you on Cyber Barbie stream, so thanks for staying with me through the raid. Appreciate that. Welcome to the channel. Glad to have you over here. All right, so we're going to change this to be able to use the keyword, to use the continue keyword. What's a scenario in which we would not want to use the continue keyword? Maybe we want to, this will be so, I don't know. This is like, it doesn't make any sense why we would do it this way, but just to show you the flexibility of what we're going to do. We could use the continue keyword to maybe we could use it to not print, maybe we can count to 100 and we can print, you know, only the even stuff. See, there's better ways to do that. It seems like a bad example, but maybe all we want to do is not print something if it's, you know, if it's not divisible by 5, or if it's one of the 5s, if it has a 5 in it, you know, maybe we don't want to print it. So let's use some of the things we learned last time and let's modify this just a bit. Let's say we're going to count to 100 instead, but we're going to say if actually no, let's say we're going to say if I mod, let's use our modulo, mod 5 equals 0, we don't want to print out those numbers. So we don't want to print out any number that ends in a 5 or 0. So we want to print out 1, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, no, not 15, 16, 17, 18, 19, 21, 22. So we want to skip 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. Yeah, we want to skip all those numbers. We want to skip those numbers. This is not the best way to do this, but we can do it this way. And so what we can do is, the break that we did before ended the whole process. The break that we did, it shut everything down. But we don't want to shut everything down. We want to keep going. And so the way we do that, we say, hey, if I mod 5 is 0, go ahead and continue. Continue. All right, you see it turned it turned a different color there. So let's mentally work through this. Now, this is still going to be an infinite loop. This is still an infinite loop, just so you all know. And we can put this back to how it was, but this is an infinite loop. So let's talk about what'll happen. It'll run through the first time. Is I mod 5, is that 0? No, it's not 0. So it'll print out 1, it'll print out 2, it'll print out 3, it'll print out 4. When it gets to 5, it'll say, is 5 mod 5 0? Yes, it is. So it'll continue. So it won't, the only reason that it won't print it out is because this continue says, hey, full stop, cut this iteration off. Don't do anything else after this. Cut it off, but move to the next one. Keep running the loop, but stop where you are. So let's see this run. And again, this will be an infinite loop, but we will not see any numbers in here that end in 0 or 5. So Python continue. It's gonna be infinite. Oh, is it gonna be infinite? Maybe it's not gonna be infinite. What do we do wrong here? Let's see what we did wrong. If I mod 5 equals 0, continue. It seems like it was just continuing over and over again, but I said print I, and I plus equals 1. What did we do here? What do we do here? Let's see. Nah, there's a chat box. No shame in using it. Lesson. You make them. This is just a lesson. Yep. I hate Miss Smurfs. Sure. This is just a lesson. And maybe missed the continue. Got all proficiencies. Yeah, maybe we missed the. Maybe continue does need a ending. I don't know. Actually, I don't know why it's doing this. That seems weird. I don't think it needs this. Oh my gosh, this seems weird. All right, let's look this. While true. Yeah, there we go. We got it. So this is why I said, this is why I put in there, this is why I actually noted here that you will accidentally create an infinite loop. You will do it. You'll do it not often, but you'll do it. Why are we creating an infinite loop here? Why is it never printing out anything? So the reason is, let's open up a new tab really quick in here. Open a new tab. Actually, not even a new tab. Python. Let's drop into the interpreter really quick. 0 mod 5. What does it equal? It equals 0. So what is happening here is, if 0 mod 5 equals 0, check this out. what is happening is the first time this runs, I is 0. First time it runs, it says, hey, is I mod 5 equal to 0? Is 0 mod 5 we just saw was equal to 0? And so it continues. And so it breaks out and it goes to the next run. And it says, hey, is 0 mod 5 0? Yes, it is. All right, continue, break out, start over again. It never makes it down to this code down here. It never gets here because of the continue statement. The continue statement ends it, starts the next iteration. And so this will never get past that. It's stuck in an infinite loop. And the way that we can fix that is to actually move this up to 1 because we never add 1. Now there's some other ways to fix this that we're going to learn about in a second. There are other loops that are better for something like this, but it's okay. It's all right. We're still making it work. Why is this happening? This is good. I like this. And so this is now going to show us how we need to do some other stuff. And while we may need to move some code around, which we do, but it prints out 1, 2, 3, and 4, and it never drops us back to the terminal. Now, you may not know this, but if you're running an interpreted program like this, and it never takes you back to the prompt where you can type, it is still running. That code is still running. And so it's still running in the background. It is going through that while we're stuck again. We're stuck for the same reason why we were stuck at 0. It gets to 5. It gets to 5, and once 5 is 5, mod 5 0, yes it is, continues, and it gets stuck in this little loop right here because it never adds 1. What can we do to fix even that? The way that we can fix that is, and again, like I said, we're just having fun here, we're messing around. There are way better ways to do a lot of these things. Let's take this, let's make it first, and let's increment before we do anything else. Let's turn this back to 0. And so this is also to show you that you don't have to increment at the end. That's the common paradigm. The common paradigm is to increment or decrement at the very end, but you can do it to wherever makes sense. This is a tool. This incrementer is a tool for you to use to control and to track the things that are going on in your loop. So let's try to do it first, and let's just see what happens. And so we say, hey, if it starts at 0, so we'll never print out 0 here, but it's going to add this here, and it's going to check if 0 mod 5 or if 1 mod 5 equals 0, continue, whatever. But it should, when it got to 5 last time, if I was 5, it prints out 5. But what happens when it's 5? It drops in here. It says, hey, go ahead and add 1 to 5. 5 now becomes 6 before it ever hits this, even with a continue. So the continue will take it back to the top, so it will iterate every time. So let's see that in action and see if this now gives us our intended outcome. And again, this is a dumb loop, and it does. You can't see, but nothing here ends in a 5 or a 0 because 1, 2, 3, 4, 6, 7, 8, 9. 1, 2, 3, 4, 6, 7, 8, 9 because of our code. So now it does in fact work. Not a pretty program at all, a dumb program at that. But again, just trying to show you that you can, there's no like, all the things that we're learning are different pieces that we can put together to solve a problem. There's no like, got to do it this way. Again, there are preferred methods to doing things that you'll learn over time, but like they're all little tools that you can kind of start to use to solve a problem. They're things you can pull out of your tool belt. You pick up loops. That's like having a hammer in your tool bag, and I know how to use a hammer now. I'm gonna put that in my tool bag, and now I'm learning conditional statements, and I understand assignment operators. Cool, that's a screwdriver. Let me put that in my bag, and let me I save that for when I need it. And that's basically what you're doing. And you're just pulling out all the tools that you need to get to your end goal when you're ready to do that. So weird little program, but we'll leave it here. I'm gonna put it in GitHub for you to mess around with, to have some fun with. But I just wanted to show you what continue does, and we saw what break did as well. They're very important concepts, and that you can create an infinite loop with this while true. Why does that make an infinite loop? Because again, this is checking for a true statement. So while whatever statement here is true, if you just set it to true, it's always going to evaluate to true, and that will allow the loop to run until you manually break out of it. So this loop runs forever. And if we wanted to break out of this loop, if we wanted to combine some things, we could say at the very end, maybe we could say if I is greater than 100, break, and it would do our code all the way up to 100. Let me remove this and remove it. It will go all the way up to 100. So now we're combining some of the things that we learned. So save this and run it, and it took us to 101, but that's fair. It did the same thing that we wanted it to do. None of these end in 0. 1 2 3 4 6 7 8 9. 1 2 3 4 6 7 8 9. So dumb program, very stupid program, but again, this is how you learn. You mess around with weird things like this, weird scenarios like this. Okay, what's up, Daspew? Welcome to the channel. Thank you so much for the follow. Good to have you. All right, I don't care if continue is supposed to have the, oh yes, hey, see, it's okay, we'll try. So you'll never just to, I've had people who were trying to troll, thinking that I knew better, and we will type something in, it's dumb, whatever. You've already seen me type in print when I went to JavaScript. It gets tough to move in between languages. Hey, throw it out, even if you're not sure if it's gonna work, even if you just have an idea, throw it out there. We'll try it. It's okay to try it. We're not, we'll try literally anything. We'll mess around and we'll just see what works. What doesn't work, we'll have a little bit of fun with it. So, hey, it's no big deal. What languages? This was Python. We're gonna do some more of this in other languages as well, especially when we get to this next piece, which is about to be for loops. But that is a while loop. Any questions so far about the while loops? Again, while true, go ahead and run this code over and over again while the scenario is true. That is what we'll be doing. Get a little water. Almost out of it. Okay. Now, do while loops, we're not going to spend a lot of time on this, but a do while loop actually would have helped maybe for our last one. But a do while loop is a while loop. It is a while loop, but it is a while loop that runs at least once, even if the conditional statement is false. And so I actually don't think Python has them. I think JavaScript does. Does Python have them? I don't know. Actually, I never use do while loops. I've never found a reason to use them, but I want you to know about them. And again, it makes sure that the loop runs at least a single time, regardless of whether or not the outcome, the conditional statement is true. And so let's see, Python do while. Let's see if there's one in Python. Like I said, I don't think there's one in Python. It does not have it. And like I said, each of these different languages will implement, it'll have similar, there are going to be ways to still achieve what you want to achieve. And so this is probably going to tell us a way that we could achieve it. But yeah, so this is kind of how it's done in like JavaScript. It's a do keyword, and then the while comes at the end. And so you might start to see how that makes sense, because it'll run some code first, and so you basically specify the code before the while condition, and so it'll run the code once first, then it'll check the while condition, and so if this is false, then it won't run this ever again, but if it's true, it'll keep running through and it'll keep going. So again, a do while loop, we don't need to, I don't think we need to do one. The only difference is that this will always run the code at least one time, and that helps. That definitely helps. Like I said, I've never had a reason to use one. Has anyone actually like found a genuine reason to use a do while loop, like in a real like project setting? Any good learning resources for new fellas? Yeah, that's it. What is it that you're trying to learn, I guess, is this my first question. But yeah, we got a fair amount of resources, but I have a lot of resources that I use as well that I'm happy to share. I really want to make like I've been meaning to make like a repo, but we started a project where we were supposed to be building out like a resources site, and we just kind of never finished it. So we just got to get less lazy and start doing that stuff. Do while is useful when the condition is based on the result of the iteration. Yeah, yes, that's true. That's true. Maybe I'll start. It's just something I never really think about, to be 100% honest. But I also, again, I'm not the languages I generally use don't have them. Like Go doesn't have it, Python doesn't have it, Bash does have do while loops. So we'll see. Cool. So that's all I want you to know about do while loops. I don't necessarily want you to be a pro at do while loops. If you start to understand while loops, you'll be able to understand the concept of a do while when you do need to hit one, and you'll find it useful then. But just know that it's a while loop, but it runs at least once, even if the condition is false. Okay, now we're into the fun ones. While loops are just as fun, but I'm a for loop. This is my preference. For loops are my preference. I very seldomly use while loops. And again, there are probably so many situations where while loops would make more sense. The reason why I use for loops usually is because I got into that habit, because Go only has for loops. It does not have any other type of loop. And so I've kind of gotten into that habit, and I end up just using it all the time. But yeah, let's go ahead and let's check this one out. So what is a for loop? This is pulled straight from Wikipedia. As you all know, I love to pull definitions from Wikipedia, but the Wikipedia definition is basically just the definition of a loop, period. But it's a control flow statement for specifying iteration, which allows code to be executed repeatedly. That is the textbook definition of a loop, even though they have it listed as the for loop definition. And so while the other one was while this statement is true, for loops, I want you to think about is this: for the following conditions, run this true. And really it's for the following conditions, evaluating to true, run the following code. That's kind of how I think is a good way to kind of help you think about the difference. One is while the statement is true, run this code. This one is for the following condition, run the following code. And these can get for loops have a number of varieties that I find were very confusing when I first started learning. Yeah, there are a couple different ways to implement them. We're gonna talk about for each and stuff next, but there's a couple different iterations or different ways that you can run through a for loop. But when would you want to use a for loop? For loops are best, again, these are best practices rather than only use them here, but they're best used when you know how many iterations of the loop need to take place. So if you know how many times you need to perform this automatic action, it's good to use a for loop, but they're also best when used when iterating over an object or a collection. So if you want to go through a collection or go through an object and evaluate all the things in there, it's best to use it for that. But it's important to know for just for loops that the object or collection must be ordered, as this method uses indices. Now, this is taking you back to data types and data structures that we learned about a little bit. Remember indexes. Remember how those collections, those lists, and those arrays are zero index. The for loop uses an index to iterate through things, and so to use a for loop, to use just a for loop, the collection has to be something you can iterate through. And what does that mean? Remember how we learned that there are some data types, there are some data structures that are not ordered. They do not have an order. Things like dictionaries, things like sets. So you cannot use a for loop. And again, this is going to be very confusing when I get to what we're going to talk about later. You cannot use a raw for loop to iterate through these things because it cannot go through unordered items. So let's just go with that for now. We'll clarify it shortly. Okay. And before we get into, so we're not gonna talk about for each, we're gonna get into a for loop, and we're gonna look at the different types, different ways you can use for loops. So we'll hit go here a little bit as well, and see that you can also use go for loops like while loops as well. But let's do it. Let's hop into a for loop. So let's open up our first for loop, for.py. And actually, I actually think here's what we're gonna do. Actually, I don't want to confuse you. I also don't want to confuse me, because I don't think W3 Schools has I I mean, not W3 schools. I don't think Python you can't for loop like this. I don't think. I just want to throw it out there to see if I'm right. I don't think you can do for iterator condition incrementer or incrementor. I don't think this format exists in Python, but let's check real quick. W3 schools, and I definitely want to show you that format. And the tutorials, learn Python, and let's learn some for loops. All right, so so they just hop you off with a for each, and I guess Python's for loop is syntactic sugar for each. Okay, so we are actually gonna use JavaScript really quick because I don't want to get into the for each. Yes, interesting. Someone who's a Python pro, let me know if Python's for loop is simply syntactic sugar over a for each. Let me know if for each is the base of it. But here we go. We'll go over that in a second because I want to get there. We'll get there. I know everyone who knows Python is like, whoa, why are you not? No, we'll get there. So let's do JavaScript really quick, and we'll come back to this one. And we'll do goes the same way. But let's go ahead and vim a for.js. Okay, now let's say we want to use a for loop to count to 100. There is a paradigm. I'm pretty sure you can do this in JavaScript. There's a paradigm of incrementer, the condition, and this is pretty hard to remember. This was like super confusing to me when I was first learning Go and stuff, like because I wasn't used to this kind of format for a for loop, and then action, I guess is what I would want to say. So this is just raw code. This is pseudocode for what it might look like. All right, this may look very confusing. It is kind of confusing. And the way that you would set it up is this whole thing right here would be a scenario that tells this for loop when and how to run. And so what you would do is, like the while loop, you would actually set up that incrementer that we were using. You would actually set it up right here. So when we set up that variable, the first thing you would do is set that up right here. And so actually underneath this, I'll start typing it as we're talking about it. So for, let's say I wanted to count to 100, I could say for I, or let I equal 0. So I set up a variable, just like I would set up a variable at the top of the file. I'll set up the variable here. And then this is where I'll set up the condition in which this loop will run. And I'll say, while I is less than or equal to 100. So that's my condition. I want to count to 100. I want to say, hey, if I is less than or equal to 100, go ahead and print out I. So that's the condition right there. And then the last thing is going to be the action. The action is going to be the incrementing or the decrementing. And so then I will say, I'll add 1 to I. So what is this saying? This is the thing that happens first. So the first time it starts, it's going to run this, and it's only going to run this when it starts. And it's going to set up I is going to be 0. Then it's going to say run this loop as long as I is less than or equal to 100. And then this is the action that it takes at the end of every iteration of the loop. So this part is very confusing. And so what'll happen is, if I say print out I, let's delete these lines. Let's close this. All right. Let's also open up the other JavaScript one next to it. Okay. This is how we would have counted to 100 with the while loop in JavaScript. This is how we would do it here. And again, we pulled basically this. We pulled it as the first thing that happens. Then this condition that exists here, we actually just set it up right here. And then we basically pulled this last thing that needs to happen. We pulled it to the end right here. So syntactically, it looks a little more confusing, to be honest, or at least to me it does. but it essentially gives us the same scenario and allows us to do the exact same thing. So let's run this and see if it runs. Let's save this and let's do node 4.js. Whoops, I did it again. I did it again. We were used to using Python there. My brain did not switch. This is JavaScript, so it's console.log instead of print. And look at that. It does in fact print out 0 to 100 for us. So a completely different paradigm. And this is a paradigm that I wanted to introduce you to. Again, I don't think that Python does not have this. Python does not have this. And so you might actually be confused at this statement here at the bottom. If you're someone who uses Python, because generally you can do this, you can generally iterate through everything with Python for loops, because I think the underlying usage is actually a for each, which we're about to talk about. But this is also what it looks like in Go. And I'm gonna go to the Go. I'm not gonna go to the Go playground. I'll write it right here. For.go. And the same thing would be here. So I would say here, I would say for I equals 1. So setting up a variable in Go is a little, and I'll put my little thing here. Oh man, I'm struggling. And I would say while I is less than or equal to 100, and I would say I plus plus, and I'll put that here. Let's close it out here. Let's take this. Let's paste it. And let's print out I. So this is what it would look like in Go. So again, ignore all the rest of the stuff, but the for loop looks similar. I may have to put this in parentheses. Again, I never remember the syntax. But I set up my iterator here, my incrementer. I set up the condition in which it runs, and I set up what happens after each iteration. And let's see if this runs. Go run for.go. And it does in fact do the exact same thing. I had to do a little compilation there, but it does in fact run exactly the same as the JS one. So I really want to introduce you to just kind of that raw for loop paradigm, because it is something that you will that you'll probably encounter, to be honest. So let's open this up next to it. And these are just the two different ones. If you focus on just here, you can see that these are almost the same bit of code. And this is actually, this is a statically typed compiled language versus an interpreted dynamically typed language. And it looks very, very similar. It looks very, very similar. So that is a kind of raw for loop. We'll see some more for options in Go, because again, Go only uses these for loops, and so you can use it like other loops. It's pretty interesting actually, but we'll get there in a second as well. What I do want to move on to is I want to move on to for each, because this is pretty important. You know what? Actually, no. Before we do that, let's do it. Let's do another example. Let's do it with JavaScript, because JavaScript is a little bit nicer. Let's modify our for loop really quick. Let's modify it. So because these for loops, and while you can do the same thing we're about to do now with while loops as well, because you can these use indices, or they can use indices, you can use this number to iterate through objects. And so let's make a let's make an array here. So let's say let colors equal what are all the colors in the rainbow? Was it Roy G Biv? Was it red? Was it green? Is Roy G Biv the colors of the rainbow? I don't know. Red, green, Roy, yellow. I'm struggling over here. Yellow. That's That's not Roy. Oh my gosh. Orange. I'm so stupid. That was dumb. Orange. Red, orange, yellow. That's Roy. G is green. G Biv, which is blue. Indigo, and violet. Sure. Let's go with that. Yes. Roy G Biv. Yes, sure. So what I just did here in JavaScript is I created a collection. So just like the list that we learned in Python, I created a collection of data, a collection of strings. Let's start practicing those things. A collection of strings. How do you know they're strings? Because of these quotation marks, words and phrases, letters, words and phrases. I created these strings here. So there are 1, 2, 3, 4, 5, 6, 7 of them in here. And so I can actually use those indexes to print out what I want. And so this is not the best way to do this either, but just showing you how you can use the incrementer. You can use this I to do things with collections with ordered collections. So if I do something like, I know there are 1, 2, 3, 4, 5, 6, 7, 8 things in here. I can say, while this is less than or equal to 7, remember, it has to be, these are 0 index. So if I want to go from 0 to 8, I need to go from 0 to 7 actually. So, you know, this is the wrong way to do it, but I can say while I is less than or equal to 7, go ahead and print out colors. Remember how we talked about we could access an item in a collection, in an ordered collection, by calling its index number. So imagine this number was, if we're trying to call the first item, if you call colors 0, color 0 will be red, and colors 1 would be orange, and colors 2 would be yellow. So because we can increment this number, we can also just put I in here as well, and it will go through and hopefully print out all the things that are in here. And so let's see that really quick. And we get red, orange, yellow, green, blue, indigo, violet, and we get undefined. We have an off by 1 area, no big deal. But it did go through, and we were able to use the indexes of this collection to be able to do this, to be able to print this information out. And so again, that's why, you know, this incrementer can be pretty important, because you can also use these things to iterate over objects that are ordered. So yeah. Yes, I could do length as well. That's the preferred method. That's why I originally said, hey, this is not the right way to do it. The right way to do this, if you want it always to be able to mess with the length, remember we learned how you can find out how many objects are in a collection or in a a certain data structure, data type, and you can do colors dot length. I think that's it in JavaScript, or is it len? Is it len at the front? We'll find out. Let's see. And that still gives me undefined. Well, I is less than colors dot length. That's why. There we go. So yes, it's dot length, and so this will always evaluate to a number. So it basically counts these up, and it goes ahead and it runs through. I could also make this. I could make this equal to, but if I made that equal to, I'd have to do colors dot length minus 1. But don't do that. Don't do that. Okay. So again, not a great case. We're going to learn how to do this a lot easier. This can be done much easier than we just did it, but there are a number of times in which you can use a for loop, or which you're going to need to use a for loop to deal with things in a collection. And so this is one way that you can do it. Now, let's learn about for each loops in a second after I check out what questions you all have. Ask any questions you have about for loops right now, because we're about to get into for each, which is still for loops. So same thing. Can you just make a tuple of integers in ascending order and use that for an iterator as a loop? You could. Interesting. That's it. That's very interesting. I've never thought of doing that. But that sounds like what range might be. We're gonna talk about that in a second. that is like the same concept. That's a pretty interesting question. You could do it. You definitely can do it. Whether or not it makes sense, is definitely arguable. W3 Schools is notorious for having bad info. It is. So yes, I will. W3 Schools is notorious for having bad info. We actually learned that when we were doing the string methods, when we were doing the capitalization, and we saw that, hey, it didn't tell us anything about it lowercasing everything that was capitalized after the first letter, whatever. But the benefit of W3 Schools, especially when you're starting out, is it is the most readable documentation out there, to be honest, because documentation, like I told you before, it's a skill to be able to successfully read and understand technical documentation. MDN, the Mozilla Developer Network, I believe, is another it's an amazing place for for information, but I find that it's a lot harder to, it's written for people who know, it's written for people who know what they're doing already. I think it's written in a way that's a little harder to parse with your eyes if you're kind of new to this stuff. So yeah, that is true. And I think it's important to call things like that out. I'm glad you called that out. It is notoriously bad for having either outdated information or incomplete information. But it'll take you a long way though, as well. Is purple not a primary color? No idea. Do rainbows only contain primary colors? I also don't know. There you go. There's your for each. See, you're doing lambdas here. You're doing arrow functions. Yes, that is how you would write it. That is the better way. Debatable, but yeah. Why collections versus arrays, are they different? No. There are, yes, arrays are, when I say collections, I am talking about I'm talking about the entirety of the data types and structures that contain more than one object of a data type. And so that's just again, maps, like dictionaries, arrays, lists, things like that. Everything like Python arrays are not really a thing, or they're kind of different than everything else, and arrays are kind of handled differently and everything. Arrays are also a part of that collection, a collection of data. Okay, so let's for each. Let's talk about for each really quick. We are actually we're making amazing time, and we're gonna mess around with stuff. But for each loops are they're amazing. For each loops are great. And before I start this out, a lot of languages again put syntactic sugar over top of the concept of a for each. A lot of them also have a couple different ways to implement for each. But for each loops are just like for loops, but they can be used to iterate over every item in a collection, even unordered collections. And this is because they do not use the index to iterate. And so that's why they're able to do that. Each language implements this differently. And so this is going to be more of the way that Python kind of implements this. We can also do this in everything else, honestly, but let's hop into a Python for each loop really quick. Vim for each .py, and so maybe we have that same let's actually grab that for loop from JS. Yank. I know this is Python, so it'll be a little bit different. Do we want that open? No. Okay, so this is our Python. Let's take these colors, and so we're gonna create a list of these same colors. And what we can do is we can do a for each loop, and this is in Python. This is just looks like a for loop, and what this does is this uses this basically sets up a state where instead of saying while this condition is true or for it's still for this condition, but it's not while it's true. It's basically for each item in this collection. So and so in here there is an iterator here, and I can say for color. This could be anything. This is a variable. I could say for I here, but I'm gonna say for color just so it makes a little more sense syntactically to you. So for color in, and you see how in change colors, this is what essentially sets up your for each, the underlying for each in Python. As soon as I put in, it's going to be looking for a collection here. So for color and colors. So this is basically saying for each color in colors, in the collection of colors, for each color in the collection of colors, go ahead and do something. This is how it's set up, and this is how it's set up in other languages as well. JavaScript has the same thing. I can say, you know, for color in colors, and again, this color right here, you might be like, how does it know what color is? This is just a variable to reference each item. So like every time it moves on to a new item, that will be referenced by this variable. So again, I can say I if I want. I could say, you know, for words in the collection colors, but we'll keep it at color. For color and colors, go ahead and print color. So why are we printing color? Color it takes the place of each value as it's iterating through. So we want to print out the color, and again, I can change it to I to make it like all the other things, but let's see this run. Python reach.py, and it goes through, and for each of the items, it performed an action for each and every item in that collection. It iterated over that thing and it worked. So let's change this to a set. Let's change it to a set instead, because remember, set is unordered. And let's after we change this to a set, let's maybe see what happens if we try to use like a while loop to do this. So for color and colors, print color, and expected one, so argue one. Oh, do I need to even call set here? Pretty sure I can I not do this? Pretty sure I can do it. Oh, there we go. I just had to not call a set there. But yeah, so I printed out. I did that just a little bit wrong. But let's do this with a while loop really fast. So I'm gonna comment these two lines out. Let's use the while loop. Again, a while loop can only use indexes because of the number. So I'm gonna say, hey, our index is gonna be, or our iterator, our incrementer is gonna be 0. And it needs to be 0 if I wanna go through all of them, because the first index is 0. And I'm gonna say while I is less than colors dot length. So that's going to give me how many items are in here. So I'm gonna say as long for basically run this as many times as items are in here. And so while I is less than colors dot length, go ahead and print I. No, I'll give me the number. I actually have to do this a little bit differently. I have to say, hey, because I is a number, I have to call colors, and I have to print the index like we did before in the for loop. So I can do the same thing with the while loop, but watch this. We're trying to print this out. It's gonna fail. Why is it gonna fail? Because it's set as a tuple, and tuples are unordered. So a for loop would work the same way a normal for loop in another language would work in a similar way to an unordered collection. But if I change this from an unordered collection to an ordered collection, this will work. No, it won't. Why didn't it work? Let's see. List object has no attribute length. What happened here? Hold on. What's going on? Length. Can you not take the length of? Oh yes. See, this is this is yes, the reason why this didn't work. That's interesting that this worked before though. So does Python have both .length and len? And this is what happens when you forget which language you're working in. Len instead of length. And oh, hold on. Why? We forgot a piece. We forgot to increment. And we forgot to do I plus equals 1. Remember, you got to increment in a while loop. So we got ourselves in an infinite loop, but there we go. So one, I only wanted to do that to show you that if this was an unordered thing, it would not work. So if you want to use the index like this, if you want to use the index to work with something, you need to be using, it needs to be an ordered collection. But a for each loop will allow you to do that. It doesn't care about those things because it's not using an index to do this. So let's remove these. And so this is how you're generally going to do things in Python. And so let's look back at the W3 schools stuff over here. And the examples will show you just that. So we have this list here for X in fruits. Go ahead and print X. This is exactly what we just did. And it will print those things out. You could also do this through other data types. So if you were to do a for each and just put a string here, it will print out each letter in the string. So let's say, get this out of here, and I can say for letter in a string. So let's go type in a bunch of stuff. Go ahead and print out the letter. And what it will do is, remember the same way that we said we can find the length of this object here of a string, it will print out each letter. So let's run that again. What just happened? It's trying to do oh, right here. Okay, it prints out each letter from the string that we just put in there individually as its own item here. And so you can do that with the for each loop. The for each loop allows you to do, again, it performs the code, it performs this action on every item in the collection, in the object. What else? You also have the break statement here. So maybe, you know, maybe I want to iterate over something, but I don't want, I want it to do everything in here, but I want it to skip a few things. I want it to skip some stuff. They have an example here, and we can just copy this to see how this works a little bit and break this down a little bit. So let's put this here. Let's put this here. All right, so what do they have here? Let's put some space here. They have fruits here, and they're gonna say for X in fruits, or for fruit in fruits, go ahead and print X. So it's gonna print out each one of these. But if X equals banana, go ahead and break out of this. So it's gonna print it, but it's gonna say, hey, if X is equal to banana, go ahead and stop this loop, exit out of this loop. So what does that mean? That means that the first run, it'll start with apple. So it'll go down here, it'll print apple. It'll say, is apple equal to banana? No, it is not. So it'll go to the next iteration of the loop, and it'll say, hey, so it'll print out banana, because it'll print X, and it'll say, hey, is banana equal to banana? Yes, it is. So it'll run this break. So it sounds like we'll never get to cherry if we are reading that properly. And let's run that. And that's exactly what happens. Apple, banana, but no cherry. Again, the same way that we use the break and the continue in our while loops, we can also use those in our for loops as well. What's up, Mr. Demon Wolf? Thanks so much for the host. How you doing? How you doing tonight? Let's see. And that's pretty important. And that was the second to last slide I had. We'll talk about range in a second. Let's go back to for each and let's practice a few for each thing. So actually, this is kind of it's such a good example of, again, the collection. If this had tons of stuff in it, we could again, it makes it super easy. We don't need to worry about the number of items in there. It will go ahead and it will apply our code to each item, or run at least for each item that is in the list. And again, you could just do all kinds of dumb things as well. But yes, for each does every item in the list without you having to worry about how many. Let's see. What's up, Toasted Zergling? How you doing tonight? What's up, Colonel Panic? Good to see you again. Welcome. Yes, I love WSL2. We were just talking about WSL2 a little bit earlier. Yes, I did actually, real quick, did Windows update 2004. I'm pretty sure we're already looking into these. Oh, so there's already issues, so it is available now. So I'll be grabbing this as soon as I can. Don't press Windows 10 update. Oh, so now it has problems, it looks like, as most Windows updates do. This is Windows Achilles heel. Like, I don't know. I really want to know. I mean, I understand why they have those problems. Unlike Mac, they're dealing with a lot of different hardware, tons of different manufacturers. But like, I don't know. They be struggling on the updates, but I'm with them. I'll continue to support because I like what they're doing. Okay, another a function of for each loops, and this is a thing in Go, this is a thing in most languages here, is this range function. And this range function is pretty nice, but it allows you to add, it allows you to add an index basically into a for each loop. I mean, so for Go it does. I think it does. I think you can do it with Python as well. But what the range function does is it allows you to iterate over a sequence of numbers. So yeah, a sequence of numbers. You can give the function a range of numbers to sequence over. The limit number is non-inclusive, and we'll talk about what that means. And you can also skip numbers. So this is what I introduced you to last time when we ran FizzBuzz. The way that we counted to 100 was we actually used the range function. And so let's look at that real quick. Vim range.py, and this is a thing in JavaScript, thing in Go. To count to 100, we did this. We said for I, and this could be anything, but we'll keep it at I, in range, and we just said range 101. You know, and we said print I. Now let's run it just to see that it does what we expect it to do. So Python 3 range.py, it does in fact, look at that, it prints to 100, prints it out. Let's look at this and figure out what the heck is happening. Range, we just said, allows you to iterate over some numbers, and so what it's doing is, I only put the number 101 here, so it starts at 0 and it goes up to the number that, if you just put in one number, it'll go from 0 up to the number that you requested, but not including it. It goes up to, but not including. So you saw it only print out 100. It does not include 101, but it goes up to 1. It goes up to 101, but it's not inclusive of 101. So it prints out up to 100. And again, the range function is iterating. It's doing a for each for the numbers that are in here. So what this really is doing is, it's really more like this. Mentally, you should be thinking about it like this: 0-100. So from 0 all the way up to 101, but not including 101. Go ahead and iterate over those numbers. But when you don't specify anything, it knows to start at 0. But you can in fact specify numbers. So I could say 1, 101. So it will start at 1 and end at 100. And so it did that again. But let's see it with 90. Let's start at 90. Start at 90. It is inclusive of this. Start at 90, go up to 101. 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100. So it counted from 90 to 100. Range is powerful. Range is really nice because it gives you, again, an easy way to iterate over a certain you know, a certain amount of things. So it essentially can replace that original syntax that we saw. You can also do things in here like length. So if you did have you know, the colors at the top, let me see if I can still have that saved here. Let's see, undo P. Nah. You can go ahead and you can use the length to set your upper limit or something like that, but you can in fact do that. Now let's talk about the step really quick. First off, kernel panic. Today has been one of the most you guys have showed me the most support ever tonight, and I can't thank you enough. Thank you so much. Hopefully all this is at the right time, because I'm still waiting for Twitch to respond to us about we submitted our partnership application. You know, I submitted my partnership application. We'll see what happens. Everyone says you don't get in the first time. I'm hoping we can be exception to that rule, but thank you. I think you're already VIP, aren't you? I'm pretty sure, but everyone who does that obviously deserves it. You are with no E, Kernel Panic. There we go. VIP. Yeah, you're already VIP. Thank you so much. Thank you for the support. Good to have you. I really appreciate you. Thank you, Mr. Deep Pockets. Yep, y'all are see, you know, I need this, because like I said, one day this year this will be, or at least my own business will be my full-time thing. So thank you. Great day for me at work. Set up a new network lab. We got to hear more about that. We definitely got to hear more about that. First off, congrats. That's great. Great day at work. As always amazing. When I have great days at work, I have a lot of great days at work. First off, I know sometimes I come in and I'm like, I had a tough day at work today, but they really do set up the rest of your day and night. So I appreciate that. Thank you. I need pockets, MG. I feel you. That's what we're all striving to have, the deepest of pockets, and that's the goal. That's the goal. I want all of you to go earn your deep pockets. Take your time. You know, lean on each other, get your deep pockets, and come back and share your deep pockets with little old me. That's all. You know, that's all I ask. You know, it's all good. So range will allow you to iterate over a range of numbers, but it will also allow you to skip. You can add a third option in here. So if I want to go to 1, if I want to go from 0, what happened? Let's say I want to go from what is happening? 0 to 101, but let's say I want to count by 5s. I can in fact count by 5s, and I can just add in something called the step. This is called the step. It's basically the start, the end, and the step. So how many do you want to skip by? And let's run that. And it goes 0, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, all the way up to 100. And that is how range works. Range is, again, it's really nice. Range is super nice. It's used exactly like this in everything that I know of. But yeah, that's how you would use it. And again, it makes it easy when you know how many iterations you want to do. You can do that. And it basically adds in an iterable item for you to use when you're iterating over. It adds in an index for you to use when you're iterating over a collection in an easy way. Oh, excuse me. So it's kind of nice. I want you to know about range. I want you to know that if you need to iterate over a number of items, an easy way for you to do that is with range. Let's actually look at this and go, but I don't necessarily need you to be a pro at that right now either. I really want you to understand the for loop though, but let's look at go by example really quick, because this also has range, so we can see what that looks like over here. And I know there's a lot of stuff here. I'll show you what to focus on. This is actually a confusing example. Oh, this is actually interesting. I knew this, but does Python's range? I'm pretty sure Python's range is only numbers. And someone correct me if I'm wrong. Let's actually just look it up. Python range function. I'm pretty sure Python can only do it iterates over numbers, whereas Go's iterates over numbers, but you can use it to, I don't think you can iterate over items here. Range itself returns a sequence of numbers starting from 0 by default, increments by 1. Oh, I forgot, actually, I think you can, do I even have to do this? I may be able to just do, does range just do this? No, it returns, it doesn't print them. But let me see anyway, I want to see, because you know, I'm curious. Okay, it doesn't. I was pretty sure it didn't, but I was just wondering. But let's see, is range for numbers only in Python? Sequence of numbers, all the examples are with this, but we'll see. We'll test this out in a second because we have time. What they're showing you here in Go, this is a confusing example. Again, this is written for people who they're not necessarily writing this for people to learn Go and how to do this in Go. Well, they are writing it for you to learn how to do it in Go, but they're assuming you already understand the concept of range. And so here they're actually using a slice here. So they're using a collection. They're using a map here. Sorry, they're using a map. And they're using that map to feed into range, and to basically say, hey, for K and V, so for key and value, I know that may be super confusing. For the key and the value here, go ahead and loop through those things. So they're using the range function here to actually iterate over a collection of data, which again, you can do here. I'm not sure if you can do this in Python. Definitely not sure if you can do this in Python. That's all for 2013. I feel you. It sounds like you love 2012. I did too. Those were good years for me. Those are my 2008 is when I graduated high school. You know, 08, the best class ever to grace the world. You know, to 2012. Those were my college years. Oh, is it 2012? 2013 to 2020. I actually maybe skipped 2013 to like 2015, and 2016 till now. Maybe skip 2020, but 2016 to the end of 2019 have been great. YGBSM, thank you again for another gifted sub. You're dope. Definitely dope. I don't know how I feel about having a train next to my name on here. That's fair, but again, you know, it's all about perspective. You can feel bad about it, and I would understand why you feel bad about it. But you know, it's okay. You're not the only person, so that's fine. First high school in 2000, but I graduated 2 years early. That's dope. First off, I did not graduate two years early from high school. I almost did not graduate purely because I went to a Catholic high school, but I did not go to Catholic school before that. And so the class that almost kept me from graduating was in fact religion. Religion class. I almost failed that class because I thought it was going to be easy, and it was not easy. I went to a school called DeMatha. In PG County. It's right side of DC. Fairly prestigious. It's interesting. We were actually just talking about it today. Like, everyone thinks it's like the super rich school. It's like, guys, it was by far the cheapest private school around. It's a really good sports school, which was one of the reasons why I went there, as well as like it's a really good academic school as well, but we're known for sports. And it's good for like it's like one of the best like national bands and like jazz bands and choirs. It's pretty interesting. But like our track practice, so we didn't have our own track or football field. We used to practice in a park, and I used to throw shot put. I did shot put and discus. We literally used to throw out of a parking lot. Like we would use the little parking stop thing as the toe board, and that's where we throw from. Like, it was fine. And people will find out, and they will be like appalled, like, why are they having you there? It's like, because that's what we have. Like, that's what we got. Like, that's what it is. Like, it wasn't weird, but yeah. But yeah, dope school. Definitely dope school. Who do you know? I might know them. My brother was actually my brother went there as well, but he's older than me, but he was actually the football coach there for up until like last year, for like the past like 7 or 8 years. So I know a lot of kids who've gone through there since then. I'm still pretty connected to the school, even though he's not there anymore. But yeah. Okay. So again, range in Python, and again, I could be wrong. We should test this. But I think it's specifically to iterate over numbers. We'll see if we can find some other examples, or if we can use those numbers to again index, go over indexable. See, it's interesting because a map like this is not ordered, but it allows you to iterate over that stuff. And I wonder if it can go if it's only for like a map, but beside the point. Just want you to know what range is. Generally it's used, you'll see it used especially at the beginning of your career, and when you're trying to solve problems, when you're Googling stuff. It'll be basically used to iterate over a range of numbers. One of the biggest things to remember is that the second number, that limit, it could be the first number if it's the only number, but the limit, whatever it's going up to, is non-inclusive, and so you can actually go down as well. But yes. I'm in high school, I play guitar. I also play guitar, but I'm pretty bad at it now. I was good for a little bit. My director passed my practice room one day and we were going to jazz band. Yeah, I wish I would have done band in high school. I did band in middle school, and I had played instruments in elementary and middle school. And the only reason I did not in high school, I think, was because I had tried to switch instruments in my 8th grade year, and my mom got real mad at me because it was really expensive. And I switched instruments and I did not practice. So I started playing trumpet, and I was actually pretty decent at trumpet in elementary school, and I started getting good 7th grade year. And then I decided I wanted to switch to percussion because, Drumline came out. So of course, Nick Cannon was my idol for a little while. Of course I wanted to be great at percussion. Everyone wanted to be great at percussion. And I switched, and I was bad. I don't know why I was bad. I could not, I can keep a rhythm. That wasn't the problem. It was like my brain couldn't figure out how to make the drumsticks or whatever I was using. I couldn't make it do what I wanted to do. It was really weird. It was a really odd thing. And so I kind of just gave up on it. And my mom had I was playing trumpet, and I hadn't gotten good at it, so she was fine. My mom was always fine in investing in me if I was committed to it. And when she bought that drum, we rented it first, and I played for just long enough to her to believe I was committed to it. And then I think we bought it, and she was like, "I'm never buying anything again." And so I did not do jazz band in high school because because of that. And the jazz band there is really at the school is really good, and I probably wouldn't have gotten it anyway, but I could have done one of the bands. We also have a really good chorus, and I did, in fact, you are looking at the 2008, we had a couple different levels of band. Our level of band was the most basic one, called the DeMatha Singers, but you are all talking to the 2008 DeMatha Singers bass section MVP. I was the best. I was the greatest. I learned all of our hymnals and all that stuff. I was killing it. I was killing it at the time. So bass section MVP, got an award and everything. Got it up. It's at my parents' house. They got it. Got my little chorus vest for my performance. It was dope. It was pretty fun though. It was pretty fun. It was fun when it was interesting taking a chorus class as an elective, and the chorus teacher was super serious, and so we started out joking around, everyone oh, it's just chorus, we just go through it, and then it becoming a super serious class, and you actually had to practice, and we're seeing a bunch of 18-year-old boys out in the parking lot, stressed out, practicing for a singing quiz, sitting out in the parking lot, no, wrong pitch, wrong note, come on, do it again. It was such an interesting thing. I don't know, it was something I had experienced. It was pretty fun. We used to really be stressed out there, cramming before a chorus quiz, because he would take you through one by one and make you sing your part without anybody else. He would sing with you, you had to do your part, and he will grade you right there on the spot. That was stress right there. Super stress, because you can't fail chorus. if you felt chorus, man, like that's a problem. That's a problem. But people were doing bad. They were doing pretty bad. But okay. Let's tangible takeaway real quick, and then we can mess around a little bit more for the time we have left, or we can answer questions or get out of here. Because again, I know that loops, I know the concepts of loops, the base concept is understandable, but I know as you start to getting into the implementation of loops, I'm sure a lot of people's brains are melted right now. And so I don't want to go into too many more examples, because I want you to be able to synthesize this, to start to break it down and understand it yourself. What are the tangible takeaways for this evening? One, that loops are a way to rerun coded instructions multiple times. That's all loops are. So that you don't have to do it, keep writing the same bit of code over and over again. You can run that bit of code multiple times. We learned about some different types of loops. We learned while loops. We learned for loops tonight. We learned that while loops basically run while a condition that you set is true. So as long as that condition is true, a while loop will continue to run. It will run until that condition is no longer true, or until you explicitly tell it to stop running with the break command. We also learned about continue. If you would like to basically tell the current run of the loop to end, but you want the loop to continue on, you can use the continue keyword with that. For that, we learned for loops. We learned that while loops, generally best practices is you want to use a while loop when you have no idea how many iterations of a loop you need to do. That's kind of the perfect use case for it, but again, not the only use case. They're interchangeable here. Then we learned about for loops. We learned about the kind of the base structure for a for loop, which was that for kind of you know, the start, the condition, and then the thing that happens afterwards, the little bit of a complicated flow, just so you can kind of see that. I think it's going to be good for you to look over that after we push this code up, just to kind of see it. It took me months to memorize that format and to really truly get it into my head, like what it was doing and what each thing meant, and how that fit into everything. And now it's my default. Like, I actually prefer to do loops that way because I'm just so comfortable with it, because I've tried it so many times now. Then we learned about for each loops as well, which will iterate over all the items in a collection. And we know that we can set that up using a for item in is generally the keyword there. And then I actually think I gave you all, actually let's go to the classroom real quick, because I think there's an example in there of how to implement some of these other loops in Go in particular. And so what's interesting about this is you can apply some of these same concepts to other languages as well, because I've been able to use I've been able to replace, use for loops in replacement for a lot of things in other languages by utilizing the same things that are in this thing here. Looping and go, yeah, looping and go. So they tell you while loop, infinite loop, for each, range loop. So let's look at the while loop here. Even though it says for, it looks exactly like what we did with the while loop. This is in Go. It looks very similar. Imagine this word is while this condition is true. And you can do the same thing in Go. You don't need to just use the for keyword instead. And just kind of keep it simple using the for keyword. So you can do that. You can actually do this in some other languages as well. Can't remember which ones. And an infinite loop. So while true, you can just set up for, just for, and it will go ahead and it will continue to run. So kind of nice. I will look through this. Not necessarily memorize it, see if you can understand it. Maybe you can't understand it at all. What I would recommend is these are pretty good examples that you can simply copy, head over to the Go playground. If you don't have Go set up locally, or you don't know how to do it locally, go ahead and just you have to put it in here and just paste it in. That's gross. Click format, it'll format it for you. And go ahead and run it and see what happens, and mess around with it. See if you can understand what's going on. The more and more you look at it, even if you look, even if you did not know how to code at all, if I were to place code in front of you and told you that you could run it using this button, you could, if you give it enough time, you could go through and you could change things in here, and just by changing things and running it and looking at it, you would start to see patterns to at least help your brain start understanding what's happening. You may not know the full scope, but you would start to get to the point where you knew that, hey, if I change this number, if I want to achieve, the number, number 400 or something down here, your brain would start to find that pattern, and you would figure out eventually how you could change that without even having to know how to code. So I encourage you to take code that already exists, run it, see what happens, change things, see how that changes the output, and your brain will start to put together, it'll start to connect the dots. You have a base knowledge over here, or sitting over here, and you kind of pick up a little dot here, you pick up a little knowledge here, you pick up a little knowledge over here, and as you're seeing these things, your brain will slowly start to connect those things, and it'll start to make sense eventually. I'm still still looks good on my end, but yeah, rewrite fizzbuzz via tail recursion. No. Maybe one day we'll get there. We are going to be talking about recursion in this class. There's one other thing one last topic I want to introduce you to that I did not put into here, and we're gonna get to here when we get to algorithms, but I want you to get your mind on it first. It's okay if you we talk about a lot, and that is nested loops. And I think it's important to talk about for really quick, because it can be very confusing. We're going to learn about functions and scope and all that later, but right now I want you to know that you can in fact do a loop inside of another loop. And so here's what we're going to do. We're going to say for let's set up an array of letters, and we're gonna do A, comma, comma B, comma C, and comma D. So we have some letters here. I could say, and I could have some numbers. So I'm gonna have two collections here. Numbers equals 1, comma 2, comma 3, comma 4, comma 5. All right, so a nested loop is a loop inside of another loop, and this is going to introduce you to a concept called scope a little bit as well. But real quick, I just want you to see it in action. I'm gonna say for I in letters, and then I'm gonna put another loop inside of this. And I'm gonna say for letter in letters, for number in numbers. All right, print. I'm gonna print letter. I'm gonna print letter, comma, number. So I'm gonna print both of these things out. I'm gonna print the letter and number. Now I'm gonna print out so you can see what it does, and then we'll look at why it did what it did. So let's do Python range.py. Whoops. Letters is not defined. Letter. Whoops. See, messing all kinds of things up. Okay, look at what it did. So it printed out A1, A2, A3, A4, A5, B1, B2, B3, B4, B5, C1, C2, C3, C4, C5, D1, D2, D3, D4, D5. Now, let's look at what it did and why it did it. So we have a loop inside of another loop. So starts here, it says for letter in letters. So that's going to be a loop. It's going to iterate over something, but that loop, so yes, that loop is going to run whatever code is inside of it, it's going to run that code before it moves on to the next iteration. So this loop begins, the top loop begins. So it goes to the first letter and letter. So it goes to A, and the code that executes on the first run of this is for number and numbers. It's another loop, print letter number. So what it does is it starts here with the first letter, it drops into A, and then this for loop right here for number and numbers. So it's going to iterate through all these things. It runs through this entire, it completes this entire for loop before it goes to the next iteration of this top for loop. Why does it do that? It does that again because the for loop is going to run whatever code is here. So I could even nest another one in here, but it's going to run through all of this before it goes back up. So the first run letter is A, but this loop says run through all the numbers. So it's going to print out letter A, and it's going to print out the first number. And it's going to go around to the next loop. So it's going to be, the letter is still going to be A because it's the first run through, but number is now 2. And then A again, but number is now 3, 4, 5. And then once it goes through all these numbers for the first time, it loops all the way back out to here. And now it moves on to B. And it drops down into here and it runs all those again. And it loops back out. And it moves to C, it runs all these. Very confusing. Nested loops can be very confusing, but sometimes they are completely necessary to solve a problem. You will see them, and again, it will always run the kind of outermost loop, or it's really innermost loop, you know, all the way through and then back up. It's wild when we get to 3 nested loops, 4 nested loops, whatever. There's usually a better way to handle something than a nested loop, but nested loops are in fact effective. And while we're learning algorithms up front, we're learning the basics of algorithms. We're going to be using nested loops to kind of brute force things. We're gonna learn how to understand it conceptually first, and then we'll get super efficient and figure out perfect ways to do certain things. At any point in this code, would letters and or numbers become an object? Yeah, in Python, they are already objects in here. So great, interesting question. Definitely interesting question. But in Python, they are already objects here. And so again, just to look back at it here, it starts out the letters, it runs through all the numbers with a given letter first, and then it moves on. And runs through all the numbers again, and then it moves on to the next letter, moves on. And so, yeah, this is both a different, this is a nested loop. It is a loop inside of a loop. It's a little bit of inception. There's a little bit of inception there, and we will do more than that. We'll do more than that later. So the range is an object too. Range is a function that returns, I believe it only returns numbers. It returns integers, and those integers are objects. Letter to upper, make it uppercase. Yes, I could make them all uppercase. I can do that. Let's do that. And that is it uppercase or uppercase? I think it's uppercase. Uppercase does the whole, or is up? I don't know. I never remember. Is it gonna let me do? I need to add in some completion. What is it? I saw you type it. I never want to look. I gotta need to look it up. Let's try this. I'm gonna do it to upper. Yeah, upper worked. There we go. So you can apply that string method onto the letters as well. But nested loops, they're used for different things. It wouldn't matter if these had different whatever, the 6, 7, 8, 9, 10. Doesn't really matter. It'll go through and it'll do it for all the items. It'll iterate through every item in each of those collections. So yeah, I was talking about range or set being an object, not necessarily. So a set is a collection of objects, but it itself, I guess, is also an object. I don't know. I'm always confused about Python's. I'm pretty sure everything in Python is an object, but yeah, range is a generator. It's basically a static function that returns a new object. It returns, yes, it returns new objects. Well, not a collection of objects. So yeah, it returns an object. It returns a series of objects, not a collection of objects. But yes, static function. We don't know what functions are yet. I'm trying to explain the things without talking about all the stuff that we haven't learned yet. But yeah. But that's it. That's it for tonight. You're gonna get your 5 minutes back. I want you all to go over this. I did in fact get I got GitHub Classroom to work. Here's what I'm gonna do for you. I need to make like 2 or 3 more changes because it took me a while to get it to start working. Tonight, I'm gonna do my best to get it tonight. If not, definitely tomorrow. Keep it on Google Classroom. It'll be available for you whenever. I'm going to both post the repo of homeworks there, as well as the code and the link to sign up for GitHub Classroom. GitHub Classroom will be nice because it'll auto grade stuff for you. It'll auto give you feedback, and you can like, it's a lot easier to collaborate and to show other people your answers and stuff like that. It's really nice. I think it's a good opportunity to test it out. But for people who don't feel like signing up for something new, if you don't have a GitHub account already or something, and you just don't feel like adding another tool to this, I will give you the code if you just want to clone the repo and try out the homework yourself. Yeah, so there's within that there's a quiz. I'm gonna see how the quiz works just there for now. Well, I guess because I'm giving you the option, I guess I need to get it into Google to the Google quizzes or whatever as well. I'll show you that. It's like a 20 question quiz, 25 question quiz, and then there's a homework assignment that has it has about 20 little like walk through scenarios, like, hey, we want to do this, like please, like set up these things. Now the first like 8, I basically walk you through exactly what to do. Like I tell you exactly, like set up a variable called this that's equal to this, and set up a thing that does this. And then as you get farther along, it'll start to remove some of the guardrails and kind of lets you kind of have some freedom to explore. Again, not super strenuous. Take your time. This is not like get it done before next class. Not at all. It's just a guide to get you going. For some of you, you may be like, oh, this is all this stuff too easy, like I'll move on, like I'm not even gonna do this. But there's a lot of people who might be like, this is perfect, right on, and somewhere where you want to start. So check it out when I send it. It should definitely be in there by tomorrow. I'm gonna try to post it tonight. The link will be in Google Classroom to get to the GitHub Classroom stuff, because it's pretty darn cool actually. So I'm kind of excited about it. But that's it. You are officially done with week 4. You're halfway through. Congratulations. Clap it up for yourselves. Pat yourselves on the back. I'm not really that flexible, but oh, there we go. I'm getting kind of flexible a little bit. Pat yourselves on the back. Again, take your time. Let's just have fun on the journey. The journey is more the destination doesn't really, the destination is a job. If you're trying to switch industries, I get it. Destination is a job, but you're always going to be learning. You're always going to be doing this stuff. You're always going to have to continue this process, maybe not as intensely, but you're always going to be on this journey of learning. So get comfortable, learn how it works for you, learn how you can do it in a way that's not overbearing, learn how you can do it in a way that you actually enjoy. Carve out time for it. I think you all are doing amazing. I love the amount of love, but 2, the amount of just interaction and the amount of excitement. Keep it up seriously. And we're gonna get to some cool stuff. I think when you run I think intro classes are always interesting because it's hard sometimes to contextualize the stuff and to do something fun with it. It always gets to a point where it's like, I want to do something with this. I want to do something fun with it. I get it. We're super close to being able to do something fun. We are almost done with the base level things that we need to kind of just be familiar with, which would be deCoded. We just got through loops. All we're going to talk about next time is functions and scopes, and we'll do intro to algorithms. next week. So next week we'll run through this, and right when we get into that intro to algorithms is when you're really going to be learning how to solve problems using code, and you're going to be learning what you probably think about when you think about software engineering, whether or not software engineering is actually that in real life. We'll talk about that as well, but this is when you'll be at the point where you're going to be at least seeing how to approach these things, and this is where we're going to start building things. This is where we're going to start doing problems. This is where we're going to start 100 days of code. We're going to start 100 days of code right after this class, and we'll start having some fun, and we'll start really taking what we've learned up here, the annoying stuff, and cementing it and really practicing it and getting our hands on and having some fun. But that's it. That's all we got tonight. I would say, you know, relax, enjoy your weekend. But again, once I release the assignments, take a look at them. No rush to do them. There's no deadline on them. Do them as you can do them. You know, if you want to just do, you know, 1 or 2 problems a night, or of the practices a night, it's okay. Take the quiz, see what you know, see what you need to do a little more Googling on. It's okay. It's completely okay. I encourage you to also, like, while you're going through that stuff, use like Google the, like, if I tell you to do, if I ask you to do something in the code and you're like, I don't remember this, reference the video, Google whatever, watch another YouTube video. This is how you'll be doing things on the job. You'll be getting the answers in any way that you can. So practice it now. It's okay. Not supposed to memorize it. And eventually you'll start to memorize certain things, and that's great. But who are we going to raid tonight? Let's see who's on. Click on myself to get to science and tech, because that's the fastest way I know how. RWX Rob is super dope. Linux shell scripting. Actually, that's really good. We've been doing a lot smaller streamers, but I do think for what we're learning, I actually think this is very valuable. Linux shell scripting is going to be using you know, Linux shell commands, bash commands, to do the same type of programming that we're learning here. So I think we're going to head over to RWX Rob, because I think I genuinely think this is super duper valuable, super like crazy value actually. So let's head on over. Let's raid. Let's RWX Rob. Let's say hello. But again, happy end of the week. If you're interested in learning about continuous integration, CI/CD pipelines, we will be doing CI/CD pipelines on Saturday. See you there. If you want to learn a little bit about that, it's okay. If you don't think you're ready for it, you can still probably learn a lot. But you know, check us out if you're interested. But peace. If not, get some rest. I'll see you next week. Keep an eye out for everything tonight or tomorrow. Keep an eye out tomorrow. Cool. Let's raid. Let's get out of here in 10 seconds. 9, 8, 7, 6, 5, 4, 3, 2, 1. Again, welcome everyone who is new. Thank you everyone so much tonight for all the love. I appreciate the hype train. Truly, truly, truly appreciate it. But let's go.